high. My fluke meter. What did I just do? I'm on DC. Okay. Turn it to ohms. This is some electrolyte. This I had sitting over there from some hydrogen cells I was messing with, and this was dirty electrolyte I changed out. And I remembered something from Robert Murray Smith about a liquid diode, and I don't know what, if he's using a KOH or exactly, I can't remember what he used in it, but it was like, electrolyte solution, like baking soda, maybe baking soda, or lye, basically. But so I thought I'd just drop in here. Well, let's see if I can show it here. This wire is connected to a piece of aluminum. This aluminum, got the wires just kind of hanging on there so it can make contact. It's just to keep it from falling inside. And this is just a piece of copper tubing that's kind of pushed down there, so it's going, you can see, it's going a couple inches into the solution, and they're kept separate. So, as a diode, now electrons flow from the negative to the positive. So, set up my meter, and I get 2.8 mega ohms of resistance, 2.869 megs resistance, trying to flow from this one to this, from the copper to the aluminum. I get 2.8 meg resistance. The other direction, trying to flow from the aluminum to the copper, is 0. There is no doing between the aluminum and the copper. So, as a diode, and this isn't a really strong solution either, it's pretty mild, really. So, working as a diode with aluminum and copper, electrons will flow from the copper to the aluminum, but they won't flow from the aluminum to the copper. So, and then there's my values I get. 2.8 megs resistance. Now, if I had 4 of these, or I took this solution, put it in 4 jars and made 4 of them, I could make a bridge rectifier with the liquid diodes. And my issue with my HHO cells has been that you need really good, high-powered rectifiers to make hydrogen, oxygen gas at a decent rate. And if you, otherwise you have to, not put very much power into it. And diodes will burn up. They tend to, because they get hot. My thought was, if I made a liquid bridge rectifier, the electrolyte that's causing the diode action between the metals could be circulated through a pump into a cooling, into a radiator, and cooled. And that way, when you're making the hydrogen, oxygen gas, and the rectification processes cause the electrolyte to get hot, it can be cooled fairly easily. And there's no solid state electronics to burn out, and there's no complex, rotational mechanical rectification, that's difficult to replicate. But yeah, so isn't that, there's what I got. It's pretty consistent on the 2.874, I mean, it's almost the same. And nothing going that way. So I'm going to get on that and make a bridge rectifier out of this. Check back sometime and I might have that. Alright, take care.